Okay, so we're going to show you a bit about how tectonic plates work in this video. Okay, so this is our Earth for pretend. Okay, let's pretend it's covered in Play-Doh. These bits of Play-Doh are representing the continental Earth's crust. Okay, the continental part of it. Okay, where the continents are, like North America. And the blue bit is representing the ocean. Okay, in this case, we're going to go with the Pacific Ocean. Okay, so there is still crust underneath the oceans. Okay, that's called oceanic crust. Okay, makes sense. This land, that ocean, oceanic crust, continental crust plate. Okay, so let's flatten it out for the sake of making it easier. Okay, so our Earth's crust is broken up into plates. Okay, so conveniently, there happens to be a plate boundary roughly at the edge of the Pacific Ocean and North America. Okay, a couple of different ways that tectonic plates can move. Okay, they can either move like this, side by side. Okay, and that's called a transform fault. Okay, there's like Los Angeles and San Diego or whatever in California. Okay, that's where there's the San Andreas Fault, and there is actually earthquakes there relatively often because the plates are moving and they slip. Right, and every time that happens, there's a release of energy because they're kind of sticky, right? And they all move at once, very slowly. Okay, so that's a transform fault. Okay, there's also a divergent plate boundary. That's where plates move farther apart and new crust is formed. Okay, and that's typically in the ocean. Okay, so let's make ourselves a divergent plate boundary. Okay, and that would be like the Atlantic Ocean has the mid-ocean ridge. Okay, so that is where seafloor spreading is happening. Okay, so the ocean floor is getting wider and bigger at a rate of 2 centimeters per year. Okay, and new ocean floor is pushing up and forming new crust. Okay, and then the ocean fills in, obviously, because it's water. Okay, so if this piece of the Play-Doh sticking out is North America, and this piece is Europe and Asia, okay, they're actually getting farther apart. Okay, so if that's the Atlantic, they're getting farther apart. So on the other side of the ocean, or the world, okay, the Pacific Ocean is actually getting bigger. Okay, so if North America's here and China's here, we're actually getting closer to China. Okay, so that was seafloor spreading or a divergent plate boundary. So far we had transform plate boundaries and divergent plate boundaries. Okay, my favorite though, take that piece of ocean off, is convergent plate boundaries. Because there's two things that can happen. One is you can form mountains. Okay, so let's pretend we have this is China, okay, and this is India. Okay, India is smashing really hard into China because the plates are moving really fast. Okay, and those plates, okay, are being formed, smushing together, and we get the Himalaya Mountains in Nepal, which is between China and India, okay, and Mount Everest is there as well. The other thing that can happen, if it's not mountain formation, okay, is something called subduction. Okay, so in this case, our plates go underneath each other. Okay, so the oceanic plate is more dense than continental plate. Okay, even though this is usually thicker. Okay, so back to this being the Pacific Ocean. Okay, and this being North America. Okay, this one is pushing underneath North America. Okay, so the Pacific Ocean's actually getting smaller. Okay, and as it pushes, it doesn't necessarily wrinkle up right along the edge. It crinkles up a little bit inland. Okay, at least in this model. So right here, this ridge would be the Rocky Mountains in North America. Okay, and in grade 8 you learn about watersheds. Okay, so everything on this side, okay, the BC side of the mountains runs to the ocean, the Pacific Ocean. Everything on this side of the Rocky Mountains runs to Hudson Bay and the Gulf of Mexico and the Arctic Ocean, which is pretty neat. Okay, so what kind of plate boundaries did we have? Transform faults. We had convergent plate boundaries, where we smush two together. Okay, either subduction happens, where one goes underneath the other one. Okay, or we have mountain formation. Smush. Okay, they get taller. And we also have seafloor spreading. Okay, now your next question might be, well, how about continental plates? Can the continental plates split? Yes, they can. Okay, so we're going to pretend this is Africa. Okay, there you go, it's Africa shaped-ish. Okay, and so South Africa's here. Okay, this is roughly where Ethiopia is. It's called the Horn of Africa. And there is a divergent plate boundary there. Okay, so eventually that little piece of Africa is going to separate itself from the rest of Africa, okay, and start drifting apart, and new ocean will fill up that space. Okay, so we'll have new, a sea. Okay, a sea is like a tiny ocean in between the Horn of Africa and the rest of Africa. How cool is that?